The creation of the universe has been a mystery for human beings and attracted huge amounts of research and science. Currently, the Big Bang is the most dominant and acceptable theory that explains this process. This theory states that the universe came into existence by expanding from a point with extreme density and temperature. Consequently, by the Big Bang event, this singular point expanded rapidly and made the current universe into the reality. This theory is supported by some mathematical formulas as well as some observations. The main observation dates back to the beginning of the 20th century, when galaxies outside of the Milky Way were identified for the first time. Edwin Hubble's groundbreaking discovery around the same time revealed that these galaxies were gradually moving apart, indicating the expansion of the universe. Consequently, if we were to rewind time, the universe would contract, eventually converging to a singular point with infinite mass. A question that might come to our mind is that next to the mathematics and some observations, would it be possible to capture light's emitted during the Big Bang and we witness the inception of this cosmic event? To answer this question, let's first see how light is generated and how we can capture it. Light is produced by the movement of electrons and releasing energy packets of photons. Specifically, light is generated when an electron in a higher than normal orbit falls back to its regular orbit. The emitted photons carry varying amounts of energy, resulting in light with distinct frequencies or wavelengths. The higher the energy and frequency, the more visibly blue the light appears, while lower frequencies will appear as red. Additionally, human eyes perceive light within specific wavelength ranges, with wavelengths beyond this range requiring specialized receivers. To make these observations visible, the captured light must be translated into a spectrum that falls within the detectable range of our eyes. With this background information in mind, let's revisit the concept of the Big Bang and explore the potential for observing it. As mentioned, the universe was created from an immensely dense and hot point where by the Big Bang it started to expand rapidly. In its initial moments, the universe consisted solely of energy. Then, in about 1 second after the expansion started, this energy underwent a transformation into subatomic particles, specifically electrons, neutrons, and protons. These particles were floating on the universe. Over time, as the expansion continued, the early universe gradually cooled down. When the temperature reached a suitable level, the protons and neurons could form the basic nucleus and attracted electrons to form the most basic atoms of hydrogen. This situation happened 380,000 years after the Big Bang. Upon the formation of the initial basic atoms, light was emitted and began its journey through space. This emitted light, now known as the cosmic microwave background, is capable of being captured. However, it remains imperceptible to the naked eye. The cosmic microwave background possesses extremely low energy due to its extensive travel over approximately 13.8 billion years. Additionally, its wavelength is too large to be visible to the naked eye. Before the era of the cosmic microwave background, no light could be emitted as the universe was composed of free electrons, protons, and neutrons suspended like a soup of subatomic particles. In this state, any light generated by electrons was deflected by others, rendering the universe akin to a foggy weather where light dissolves, invisible from a distance. Hence, the cosmic microwave background stands as the oldest observable light from the universe, marking the boundary of visibility to around 380,000 years after the universe's formation. And it shows that the starting point of the universe will remain unobservable to us forever.